So now we'll continue in sets. So next thing we'll see in the sets is symmetric difference of two sets. So next thing we'll see is symmetric difference of two sets. So symmetric difference of two sets means, like suppose if we take two sets, and if we talk about the symmetric difference of two sets, then symmetric difference of the two sets, let's say A and B are two sets. So the symmetric difference of the two sets A and B is said to be as equal to A minus B union B minus A. This is what to be said as a symmetric difference of two sets. So that is A minus B union B minus A, and it is generally denoted by A intersection B. So this is what you mean by the symmetric difference of two sets, that is A minus B. We have already seen what do you mean by A minus B and B minus A. So the union of A minus B and B minus A is said to be as the symmetric difference of two sets. So like suppose if we take one example in this, so we first write down the example is if A is equal to X belongs to R and X is between 0 to 3. So this is the set A which is defined, and accordingly we'll take the other set B and accordingly we'll define it as X belongs to R and X is from 1 to 5. So this is how we have defined set A and B, and we need to find out A symmetric difference B. So we need to find out the symmetric difference of set A and B. So this is the sign which we generally use to denote the symmetric difference. So now we'll see how to solve this question is, what is said here is, if A is given as a set, that is that X belongs to R and X is between 0 to 1. It is X belongs to a real number which lies between 0 to 3, not 1, it's 0 to 3, and both 0 and 3 are not included. And B is the set in which again X is a real number, but in this case X is from 1 to 5, both are included. So now we need to find out the symmetric difference of set A and B. So first we'll find out A minus B. So first we'll see what do you mean by A minus B. So A minus B, if we'll see, A minus B is a set which is A minus B is what do you mean by A minus B? A minus B is actually the thing which is there of set B. If we remove that thing from set A, so that thing is generally said to be as the A minus B. Or how we can define it like this, like if we talk about two sets A and B, and there is something common in both sets A and B, that is what we mean by the intersection of sets, or A intersection B. So if we remove that intersection part from A, so the remaining part is said to be as the A minus B. Here if we see A minus B, definitely A minus B is the set in which X belongs to the real number, and here X can be defined from 0 to 1. Why we have defined X between 0 to 1 is definitely we need to remove the part of the set B from set A, right? So like if set A is from 0 to 3, so we have removed the part B from set A. That is one. That means that we have removed, that we need to remove the elements which are there in set B from set A. So if we see the common part of A and B, common part of A and B, then common part of A and B is the region that is from 1 to 3. If we see the common part of A and B, that is A intersection B, that is X belongs to real number in which X is from, if we see the common part of both are X is from 1 to 3. So this is the common part of both. Okay, so this is the common part of both if we talk about the common part of A and B, that is X is from 1 to 3, right? So this is the region that is common in both. Now we need to remove this region from A to get A minus B. So accordingly it means in this case of, if we have seen A intersection B, X lies between 1 to 3, only 1 is inclusive. So it means we need to remove this 1 from A minus B. So accordingly we will get the set A minus B. So that's why we have taken, for A minus B, we have taken x from 0 to 1. So we have removed this 1, because the part of B should be removed from A to get A minus B. And this 1 is common in both A and B. So we have removed this B, part of B, from A. So accordingly we got A minus B as x belongs to real number where x is from 0 to 1 and both are not included. Now similarly we'll find out B minus A. So B minus A is the set in which x belongs to again real number, and here x lies between 3 to 5, both are included. Why between 3 to 5? Now in what we need to do in B minus A, we need to remove the common part of A and B from set B to get B minus A, or we can say it like this, that we need to remove the part of A from B to get B minus A. B minus A, or we have already seen, B we have already seen is the x contains the x elements which belongs to real number, and x lies from 1 to 5, both are included. So definitely if we see intersection B is x which lies between 1 to 3, only 1 is included. So it means we have removed that common part from B. So that, as we have removed the common part from B, we got that B minus A B minus A lies between 3 to B minus A is a set of elements in which these elements lies between 3 to 5, and both are inclusive. So how we got this is, if we need to analyze this, how we got this is, like if we see the set B is the set which contains the elements starting from 1, let's say 1, 2, 3, in this way all up to 5, all real numbers are there, and we have removed this A intersection B part from this. So if we see, A intersection B part is the part which is having the elements 1, 2, and similarly up to 3, in which 3 is not included. So we have removed all these elements from B. So accordingly we got B minus A. So that's why we got B minus A is a set of elements which is from 3 to 5, and both are inclusive. 3 and 5 both are inclusive. So now we need to find out the symmetric difference of A and B. So that will be equal to A minus B union B minus A. So we need to find out the symmetric difference of both the sets. So A minus B union B minus A. So we know that A minus B is the set of elements. A minus B is the set of elements in which x belongs to real number and x lies between 0 to 1. Similarly, union. Now union B minus A. B minus A is the set of elements in which x belongs to a real number and x lies between 3 to 5. So this is what do you mean by B minus A. Now we need to take the union of both these sets. So now if we take the union of both these sets to get the symmetric difference, then accordingly what we'll get is x belongs to real number in which x either lies between 0 to 1 or x lies between 3 to 5, both included. So this is what we mean by the symmetric difference of A and B. So we have taken either x lies between 0 to 1, both are not included, or x lies between 3 to 5, both are included. This is what we mean by the symmetric difference of two. So now we move on to the last type of set is complement of a set. Complement of a set. Now what do you mean by the complement of a set is? So first we will see what do you mean by the complement of a set. So if we need to find out the complement of set is, complement of set means, like suppose if we take set A, then complement of set A means that if we remove all the elements of set A from the universal set, so the remaining elements is said to be as the complement of that particular set. Like suppose if we'll take the example, like suppose we'll take this as the universal set. Universal set means the set which contains all the elements. Now we'll take another set A. This is a set A. So it means the complement of A. Complement of A is the, if you remove all the elements of A from the universal set, the remaining elements are said to be as the complement of A. Like this whole region is defining the universal set. That is, this whole region contains some elements, and this circle region defines the elements of set A. So if we remove this element of set A from this universal set, then accordingly we will get this region, this shaded region. So this shaded region is said to be as the complement of set A. So this shaded region is said to be as the complement of set A, and it can be written down like this, that A and C here. So this denotes that this is the complement of set A, or it can also be written as A dash. So this both things denotes that this is the complement of set A. This is what do you mean by the complement. Okay, so this is what do you mean by complement. So complement means removing the elements of particular set from the universal set is said to be as the complement. So now we'll see one example based on this complement. So let take the universal set as 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the elements in this universal set, and let's take the set A. So set A is, let's take the elements of set A as 1, 2, 3, 4. Similarly, let's take set B. So elements of set B as 2, 4, 6, 8, and similarly we'll take another one more set, that is set C, and let's take the element of set C as 3, 4, 5, 6. So what we need to find out? We need to find. So there are a few things that we need to find out in this is, so first thing we need to find out in this is A's complement. So now for A, as we need to find out A's complement, so accordingly we know that A's complement is, if we remove the elements of set A from the universal set, we'll get the elements, and those elements are said to be as the complement of A. So as we know that A has the elements 1, 2, 3, 4, and the universal set has the element 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means if we remove 1, 2, 3, 4 from the universal set, the remaining elements are said to be as the A's complement. So A's complement in this case is the elements that are 5, 6, 7, 8 and 9. So these are the elements of the set of A's complement. So it means A's complement will contain these elements 5, 6, 7, 8 and 9. This is what do you mean by A's complement. That is, we have removed the elements of set A from the universal set. So the remaining elements are the elements of A's complement set. So now the second is we need to find out A intersection C's complement. So in this, first we need to find out A's intersection C. A's intersection C means the elements which are common in both A and C. So the elements which are common in both A and C. So if we say A and C, then the common elements of A and C are 3 and 4, because 3 and 4 are the elements which are common there in both A and C. And now we'll need to take the complement of this intersection. That is, we need to remove this element 3 and 4 from the universal set to get A's intersection C's complement, and the remaining, if it means we need to remove this 3 and 4 from the universal set. So the remaining elements are the set of elements of the set A intersection C's complement, and the elements are 1, 2, 5, 6, 7, 8 and 9. So these are the elements of A's intersection C's complement set. This is what do you mean by A intersection C complement. Now in this way we'll take the another set, that is A, and we need to find out now is A union B's complement. So first we'll need to find out A union B. So A union B means the set of A union B set contains all the elements of A and B. Means whether they are common or not in both A and B, it doesn't matter, but it should have all the elements of A and as well as B. So now we'll take all the elements of A and B. So it means we will get A union B as 1, 2, 3, 4, 6 and 8. These are all the elements which are either in A or in B or both. So A union B contains all the elements which are either in A or in B, or either they are in both A and B. So those are considered to be as the A union B. Now we need to find out A union B complement. So A union B complement will contain the set of elements which are not there in A union B, and it means we need to remove the elements of A union B from the universal set. So A union B contains the elements 1, 2, 3, 4, 6 and 8. So these are the elements which are there in A union B, and now we'll need to now we need to remove these elements from the universal set. So accordingly we'll get the elements as 5, 7 and 9. So these are the elements which are there in set A union B's complement. This is what we mean by A union B's complement. And the last question in this is we need to find out B minus C's complement. So if we need to find out B minus C complement, so first we'll find out B minus C. So as we know, B minus C means which the elements which are the elements which are there in both B and C, we need to remove those elements from set B to get the elements of B minus C. So first we'll see what are the elements which are common in both B and C. So it means first we'll find out B intersection C. So B intersection C will contain the elements which are there in both B and C, and those elements are 4 and 6. So these are the two elements which are there in both B and C, 4 and 6. Now we need to remove these elements from B to get B minus C. So it means we need to remove 4 and 6 from B to get B minus C. So if we remove 4 and 6 from B, we'll get the elements 2 and 8. So these are the elements which are there in B minus C. And now we need to find out B minus C's complement. So B minus C's complement is that it means we need to remove the elements of B minus C from the universal set. And the elements of B minus C are 2 and 8. So if we need to remove this 2 and 8 from the universal set. So we'll get 1, 3, 4, 5, 6, 7 and 9. So these are the elements which are there in the set B minus C's complement.